Hello students. In our previous classes we have discussed about the commonness in all acids and all bases. So hydrogen ion is common in all acids and hydroxide ion is common in all bases. And also we have learned about the dilution process of acids and bases. So to distinguish between acid and bases, we also come to know that acid-base indicators are used. So when we diluted the acids, then the concentration of hydrogen ion will less per unit volume, as well as when we diluted the base, then concentration of hydroxide ion per unit volume is decreases. So that means when we diluted, the amount of hydrogen ion or hydroxide ion is decreases, but how much uh, ions are present in this solution we cannot determine. So to determine or to judge the strength of a given acids or a base, we have to use a universal indicator. So this universal indicator is made by a mixture of several indicators, and the universal indicator shows different color at different concentration of hydrogen ion in solution. So actually universal indicator paper is like that in color. When we added acids, suppose we are adding hydrochloric acids, then the color changes. So it is depending upon the amount of hydrogen ion present in the acids. When we added HCl, then the color will show this color. When we added lemon juice, then it shows the color. Like that. Similarly, when we added base sodium hydroxide, then it shows the color, this color. So actually the color will changes in the universal indicator paper depending upon the concentration of hydrogen ion present in that solution or acids as well as bases. So for measuring that hydrogen ion present in the solution or hydroxide ion present in the solution, we have to use a scale, and that scale is known as pH scale. Okay, so this pH scale, in pH scale P, which stands for potent. Potence mean power. It is a German word. Potence mean power. So on the pH scale again, generally it will start it from 0. It is very acidic, and to 14 it is alkali. So it is here. I will show you pH scale. This 0 to 14. So this shows the variation of pH, the change in concentration of hydrogen ion and hydroxide ion. So what is mean? The pH should be thought of simply as a number which indicates the acid or basic nature of solution. Higher the higher the hydronium ion concentration, lower the pH. So hydronium ion or hydrogen ion. Okay. So if the hydrogen ion is higher, then its pH will be lower. That means here the pH 0. So in this level hydrogen ion is much more. Here is pH 1 suppose, then this much is hydrogen ion or hydrogen ion. So in this scale it shows the variation of hydronium ion as well as hydroxide ion. So pH of a neutral solution is 7, so it is the middle point 7. So in 7 this is the middle point and this level is the neutral level. So there are some substances are there, example pure water which is neutral in solution. Okay, neutral. Again pH less than 7, this is 7, and when it less than 7 this side up to 0, then the substance or this solution are in acidic condition. Okay, again more than 7, pH when more than 7, then the solution are in basic condition. Okay, so this scale shows that pH from 0 to 14, and the middle one is 7, the neutral one. So when pH decreases from 7 to 0, the amount of hydrogen ion is increasing. Okay, and when pH changes from 7 to 14, that means increasing, then hydrogen ion concentration is less, amount of hydrogen ion concentration decreases. But when pH is less than 7, that means pH is decreasing, then this hydroxide ion OH minus ion level is or concentration is decreasing. And when pH is increases to 14, that means from 7 it is increasing towards 14, then what is happening here, the basic character increases as well as concentration of hydroxide ion is increases. So that is generally there are indicator papers, and this indicator paper shows color in different condition of hydrogen ion concentration, and in different acids or different substance shows different color when we apply some substance in universal indicator paper. So this shows the scale, pH scale. When it is red in color, that means that solution is very strongly acidic. Orange color, saffron, orange color, like that, the acidic character is decreases. And when the solution of the pH is dark blue, then it is very strong bases. So sodium hydroxide when added in the universal paper, indicator paper, then color shows this position. So here I have shown that these are the pH is when pH is 1, that means lesser the pH, higher the hydrogen ion concentration. So pH 1 is stronger, greater than pH 2, that means acid is pH 1 is more acidic than pH 2 solution, pH 2 solution more acidic than pH 3 solution, like that, it's more acidic than pH 4 solution. Okay, so pH 1 is strong acid, pH 2 is less strong acid in comparison between these two. So this is the universal indicator paper. So there is the activity given. In this activity you have given the table and you have to fill up the table. So saliva before having meal, the color of pH when we add it in the universal indicator paper, what will be the color you can find in this scale, pH scale. Okay, appropriate pH, if it is by adding saliva before meal, if it is in this color, okay, then pH 1 indicates gastric juice, or we can say hydrochloric acid, isn't it? pH 1, then we can write pH 1. Nature of the substance is, we can write acidic, okay, more acidic. Saliva after meal. So by testing the universal indicator paper, the color will change, and if what color will be changed through this pH scale, we can measure and we can write here in this table. Okay, so when we add hydrochloric acid in this universal indicator paper, then color will come to this level. Okay, so pH will be 1. In hydrochloric acid, pH will be 1, strong acid. When hydroxide ion will be added, then it will be colorful in this sodium hydroxide added, then color will fall in this level, so pH will be 14. So strongly, your strong basis. Tomato juice, lemon juice, when we added, then this color shows here. Okay, pH 2. Pure water, then pH will be 7. Blood, then pH will be 7.4. Slightly basic. So what is written here? Look, the strength of acid and bases depend on the number of hydrogen ions and hydroxide ion produced respectively. If we take hydrochloric acid and acetic acid, the same concentration, say 1 molar, then this produce different amount of hydrogen ion. Here suppose I have taken HCl hydrochloric acid, and here I have taken acetic acid, H3, H2, OOH. So in between this, when we take 1 molar, then the amount of hydrogen ion is not same in between these two. Okay, in case of the HCl, the amount of hydrogen ion is comparatively much more than amount of hydrogen ion present in acetic acid. So this indicate the strength of the acid. So hydrochloric acid is stronger acid and acetic acid is weak acid. Okay, similarly we can identify the bases. Sodium hydroxide is very strong basis. Magnesium, meal of magnesia, it is a weak base in comparison to sodium hydroxide. Okay dear students, thank you.